time to begin. I'll count it in. 5, 6, 7, 8. My boots good and baby is dry.
In this video we're going to look at how to find the nth term of a sequence. If you haven't already watched the video on generating sequences, you might want to go back and have a look at that. There's a link to that at the top of the video now. To find the nth term of a sequence, the first thing we do is we look at the difference between the terms. So in this sequence you should be able to see there's a rule that we're always adding to get from one term to the next. This means that our nth term must have a 2n in it. So we can write that down here, 2n. Now this sequence here isn't 2n because the 2n sequence is the 2 times table, but this starts with 5. So what we do is we write the 2 times table above the sequence, 2, 4, 6, 8, 10, and 12, and we say how could we get from this sequence, the 2n sequence, 2, 4, 6, 8, 10, 12, to our sequence, 5, 7, 9, 11, 13, 15? And the answer is, to get from this sequence to our sequence, we're always adding 3, because 2 plus 3 is 5, and then 4 plus 3 is 7, 6 plus 3 is 9, and so on. So this sequence is 2n plus 3, because you've got to add 3 to all of the 2 times table numbers to get to our sequence. Let's have a look at another example in exactly the same way. To get from one term to the next this time, we're adding 5 each time, which must mean that this is a 5n sequence. So if we write the 5 times table above this, 5, 10, 15, 20, and so on, then we need to look for a link between the 5 times table, 5n, and our sequence. Now this time it's not adding anything, in fact it's taking away 4 each time, because 5 take away 4 is 1, 10 take away 4 is 6, 15 take away 4 is 11, and so on. So it isn't the 5n sequence, it's 5n take away 4. Okay, here's 4 sequences for you to have a go at. Press pause, have a go at them, press play, and I'll take you through the answers. Okay, here are the answers. The first sequence goes up in 3s, so it's a 3n sequence, and it's 3n plus 4 because you'd need to add 4 to each of the 3n terms. The next sequence goes up in 2s, so it's a 2n sequence, and it happens to be 2n plus 4 because you'd need to add 4 again to all of the 2 times table numbers to get our sequence. The next one here is a 4n sequence because it's going up in 4s, and it's 4n take away 1, because if you take away 1 from all of the 4 times table numbers you get these. And the final one is 2n because it's going up in 2s, and take away 1, because if you take away 1 from 2, 4, 6, 8, 10 you get 1, 3, 5, 7, 9. Okay, this next sequence is slightly different. You should notice straight away that it goes down in 2s rather than going up. It's a subtraction sequence. This means that the nth term, rather than being something like 2m, is actually going to be minus 2m. And you do the rest in the same way, but instead of writing the 2 times table above, we write the minus 2 times table. So minus 2, minus 4, minus 6, minus 8, minus 10, and minus 12. And we ask ourselves the same question again. How would we get from the minus 2 times table to our sequence? How do we get from minus 2 to 12? How do we get from minus 4 to 10, and so on? And in this case, it's add 14. So the sequence is minus 2n, add 14, because minus 2 add 14 gives you 12. Minus 4 add 14 gives you 10. Let's have a look at one more, just like this. Again, it's a decreasing sequence, and we're taking away 5 this time. So it must be minus 5n in the nth term. So we write the minus 5 times table above, minus 5, minus 10, minus 15, minus 20, minus 25, minus 30. And we say, how do we get from minus 5 to 9, and minus 10 to 4, and minus 15 to minus 1, and so on? And in this case, we are adding 14 on this time, so it's plus 14. Okay, here's 4 of these for you to have a go at. Again, they're all decreasing ones this time, so you're going to have a minus. Press pause and have a go at them. Press play and I'll take you through the answers. Okay, here are the answers. This first sequence is going down in 2s, so it's minus 2n, and it happens to be minus 2n plus 11. This next one is going down in 4s, so it's minus 4n and plus 19, which is what you need to do to get to our sequence from the minus 4 times table, and minus 3n and plus 13, and finally minus 5n plus 10. Okay, there's one final type of sequence. Now, when you start to look at how to get from one term to the next in this one, it's a little bit different. You have plus 3, but then plus 5, and then plus 7, and then plus 9. So actually this sequence isn't what's called a linear sequence. It doesn't go up by the same amount each time. In fact, the amount that it goes up by, or down, is changing itself. It's another sequence. Now this sequence happens to go up in 2s. The result of this is that the nth term of this sequence must be an n squared sequence. And n squared simply means the square numbers, 1 times 1, 2 times 2, 3 times 3, and so on. So what we do is above the sequence, rather than writing out the, say, 3 times table or 5 times table, we write out the square numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Now it should be clear that there's a link between the square numbers and our sequence. So how do we get from n squared to our sequence? What do we do to each of these terms? And in this case it's just plus 2, because 1 plus 2 is 3, 4 plus 2 is 6, 9 plus 2 is 11, and so on. So this sequence is n squared plus 2. Okay, here's 4 mixed up questions for you to have a go at. Some of them may be increasing, decreasing, or even an n squared sequence. Press pause and have a go at them, press play, and I will take you through the answers. Okay, here are the answers. The first sequence is going up in 3s, so it must be a 3n sequence, and it is 3n plus 2. The next one isn't going up by the same amount each time. In fact, it goes up 3, 5, 7, 9, so it must be an n squared sequence. And to get from the square numbers to our sequence, you need to add 6. So it's n squared plus 6. The next one's going down in 3s, so it's minus 3n and plus 11. And the final one is going up in 3s, so it's 3n, and you need to take away 1 from the 3 times table to get our sequence.